Hello, and welcome to our 2.2 notes, angles in standard position. Objective 2.2 says I can graph angles in standard position, and that's what we're going to learn how to do today. So first, let's talk about standard position. Standard position is an angle graphed on the coordinate plane So when I say coordinate plane, I mean like the XY coordinate plane we're familiar with the vertex at the origin, an array on the x-axis. So what I mean by that is our vertex of the angle will be centered at where we would put 0, 0, and then we'll have a ray on the positive x-axis. So it'll be going to the right from 0, 0. So that'll be one side. The other side of our angle is the terminal side, and that's the side that rotates. And I'll put rotates in quotation here. Rotates around the origin. So we'll always have one angle on the positive one ray on the positive x-axis, but then we'll have one that rotates around the origin to write our angle. So when we're writing angles in standard position, when we're drawing angles in standard position, we want to make sure to include the following things. We want to make sure that there's two rays, obviously one on the positive x-axis, like I said. We're going to have the arrow of rotation because we're going to learn about positive and negative angles, where positive angles rotate counterclockwise and negative angles rotate clockwise. So counterclockwise, remember, would be this direction. Clockwise would be this direction. And then we're also going to write our measurement. And that's important because we're not going to be exact here. We're going to be close, but obviously it's not like we're getting a protractor out to make these perfect angles. That's not the goal here. So let me show you what I mean with these things. So let's do some examples of drawing angles in standard position. So 330-degree angle. So think that's just less than 360. So that's 30 degrees short of a full rotation, right? So I'm going to have one ray of my angle on the positive x-axis, and then this would be 90, this would be 180 degrees, 270 degrees, and then 360 would be all the way around. So my ray is just going to be, this is my terminal side, it's going to be just short of 360, right? Think about having like 30 degrees in this space here. So that is my two rays. Now the arrow of rotation tells me, since this is a positive angle, I'm rotating in a positive direction, like so. So what this is showing is that if I started here, I would go around here to get 330 degrees, and that's my measurement, right? So this right here is everything that we need. We have two rays, we have an angle of rotation, and we state the measurement. So let's look at this one, negative 250. So we start on the positive x-axis. This would be negative 90. This would be negative 180 degrees. This would be negative 270 degrees. So negative 250 is going to be just short of that negative 270 degrees. Since this was negative, it's rotating clockwise like so. And I would say negative 250 degrees. There we go. Now, notice also it asks us to identify the quadrant where the terminal angles lie. So just a refresher, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So for letter A here, we would have ended up in quadrant 4. For letter B, we would have ended up in the second quadrant. Very good. Okay, so let's go ahead now. Let's do some in radians, okay? So this is 5 pi over 4. Now, what I don't want you to convert this to degrees. I want you to be comfortable enough to use radians. So let's recall that 2 pi is a whole rotation. So that'd be the same as 8 pi over 4, right? That's 8 pi over 4. That means right here would be 4 pi over 4, 1 pi. This would be 6 pi over 4. This would be 2 pi over 4, right? Pi over 2, 3 pi over 2. This is pi over 2 up here. So if I want 5 pi over 4, that's going to be right in between 4 pi over 4 and 6 pi over 4. So that means I'm going to have my terminal side coming out from right there. My initial side there, 5 pi over 4, positive rotation, like so. And then we would say 5 pi over 4. And that ends in the third quadrant. And then we have pi over 6. So pi over 6. Remember that this is pi over 2. Pi over 6 is going to be really a thin angle here. So for this one, I would show my positive angle opening and say pi over 6. Make sure we demonstrate that measure. And that ended up in the first quadrant. So that's how we graph angles in standard position, okay? So a couple things to review. Our two rays, one of them is always on the positive x-axis. Our arrow of rotation, we're going counterclockwise if positive, clockwise if negative, and it's important that we show the measurement, right? Be sure to show that measurement. This isn't exact, so it's important that that label's there so we can communicate what angle we're graphing. Okay, so let's go ahead and try to answer a couple of these questions. So for the is this angle positive or negative? So we see this angle here. Since it's opening clockwise, we can tell right away this is negative. What quadrant is the terminal side in? Terminal side is the side that rotates, so this would be the third quadrant. What's the angle measurement in degrees? Well, if this is 65 degrees and this is 90 degrees, 90 plus 65 is 155. So this would be 155 degrees. What's the measurement of the angle in radians? Oh, okay, so let's convert 155 to radians. So that'd be 155 times pi over 180. Let's see. I know I can divide both of those by 5. What is 155 divided by 5? 155 divided by 5 equals 31. Now 180 divided by 5 is 36. And I can't simplify that any further. So this would be 31 pi over 36. Now notice, these are negative, so we need to include those negative degrees, right? This is a negative angle. So we need to include that in our measurement. Negative 155 degrees and negative 31 pi over 36. Let's look at this next one. So looking at letter B, is this angle positive or negative? Well, this angle of rotation tells us we're opening counterclockwise, so it is positive. What quadrant is the terminal side in? This is the second quadrant. What's the measurement of the angle in degrees? Okay, well, if this is 60 degrees here, that means that this here is 30 plus 90. 30 plus 90 is 120 degrees. And now to convert that to radians, so I do 120 times pi over 180, which will become 12 pi over 18, which is 2 pi over 3. Very good. And of course, these are positive angles, so we have that there. Very good. So there's another way that we might see it. So instead of giving the exact measurement, they're giving us, this is called the reference angle here, or they're giving us the continuation of what we don't see. So this is 90, 65, and we can build from there. So let's talk about coterminal and reference angles. Coterminal angles are angles that have the same terminal side. The same terminal side in standard position. And you might have heard me talk about the reference angle just a bit ago. Reference angles are the angle created by the terminal side and the x-axis. Okay, so let's say here that if I'm graphing an angle, let's do this in blue and then we can graph it in black here. If I'm graphing an angle and I have something that looks like this, and we'll say it's positive and we'll say this is 135 degrees. So my reference angle would be this space here. This would be my reference angle, the angle created by the x-axis and the terminal side. That would be my reference angle. Now, a coterminal angle, let's say we have, let's do this on a different coordinate plane. Let's say we have an angle, it can be 135 again, I suppose. So 135 degrees. The opposite, or if I have a negative angle that goes to that same spot, let's see, that'd be negative 225 degrees. That would be a coterminal angle. So 135 and 225 degrees are coterminal angles. I also could have an angle that is more than 360 degrees. It's an additional rotation. That would also be coterminal, so long as it ends at the same spot. So to find coterminal angles, if we're in degrees, we'd take our degree and we'd add or subtract 360. We're basically adding or subtracting a rotation. To do it in radians, we would add or subtract 2 pi. We're adding or subtracting a rotation because if I have that angle, let's say it's here now, I could get it this way, I could get it this way, I could go all the way around, get it that way. All of them end at the same spot, and that's the idea behind coterminal angles. They all end at the same spot. So, find the coterminal angle within one rotation from 0, then graph the original angle, state the quadrant, and the terminal sides. Awesome. So 28 pi over 9. Think about 2 pi over 9 would be 18 pi over 9. So this is more than one rotation. So let's subtract 18 pi over 9. And when I get that, I would get 10 pi over 9. So that's one coterminal angle. I could subtract 18 pi again. And I would get negative 8 pi over 9. That would be another coterminal angle. I could do this process an infinite number of times and I would consistently be getting coterminal angles. Now 10 pi over 9 is pretty easy to graph. Goodness, let's shoot back up to the top here. 10 pi over 9 is pretty easy to graph if I think, well, 2 pi over 9 is a whole rotation. That's 18 pi over 9. So that means this is 9 pi over 9. So we're going just a little more than that x-axis, something like this. So that right there is 10 pi over 9 if I have this rotation. It's negative 8 pi over 9 if I have this rotation. But remember, the angle I'm trying to graph is 28 pi over 9. So that is one whole rotation all the way around, and then we continue to there. So this here would be 28 pi. Oh, I forgot the 8. 28 pi over 9. Very good. Okay, so we have everything graphed here. We ended in the third quadrant. What would my reference angle be? So remember, my reference angle is this angle here, and it is pi over 9 past 9 pi over 9. So that right there would be my reference angle, pi over 9. Awesome. Let's try one in degrees. So this time, negative 510, that's more than one rotation in a negative direction. So to get that between, to be a rotation closer to 0, I would need to add 360. So what is negative 510 plus 360? Well, that would give me negative 150 degrees. So there is one coterminal angle. I am basically adding a positive rotation. And then I can do it again. I can add 360 to that and say, well, what happens if I add another 360 degrees? I get 210 degrees. Okay? So all of these are coterminal angles in that they end at the same spot. So think about here we have 180 degrees. We would have 270 degrees here. So my 210 degrees is going to end up about 30 degrees past 180, right? However, again, I can use that to graph, but that's not the actual angle I'm graphing. I'm really graphing negative 510 degrees. So if I'm graphing negative 510, I want to have negative rotation. So I'm going to go one entire negative, so that's negative 360, and then I need to go negative 150 degrees more to give me that negative 510. So I would label this negative 510 degrees. I ended in the third quadrant. And remember, I originally graphed that 210 degree angle right here, and 210 is 30 degrees more than 180. So I can tell you this reference angle is 30 degrees. All right. Last thing to do, what if it's already graphed for us? What information can we gauge from this? So, is this angle positive or negative? Well, we can see that it is a positive angle because it's rotating counterclockwise, right? We are starting here and going this way. There's one whole rotation, so we know it's 2 pi. What quadrant does the terminal ends in the 4th quadrant? What's the measurement of the angle in degrees? Well, let's figure it out in radians first, because that's what they give us here. So this right here would be 12 pi over 6. That'd be one entire rotation, 12 pi over 6, 2 pi. And then I need to go 3/4 of that, so that would be plus 9 pi over 6. And then I need to go one more pi over 6, so plus 1 pi over 6. When I add all that up, I would get 22 pi over 6. So that is my measurement in radians. Now, what's the measurement of the angle in degrees? Well, to convert, I do 22 pi over 6 times 180 over pi. The pi's cancel, so I would do 22 times 180. It's 3,960, and I'm dividing that by 6, and I get 660 degrees. So see how we're getting angles that are more than one entire rotation, and we can see that from the rotation. That's why showing that rotation is so important. So let's do another. Let's do B here. Is this angle positive or negative? Well, we are going in a positive direction here, so we know it's positive. What quadrant is the terminal side in? The terminal side is in the 2nd quadrant. Okay. What's the measurement in degrees? You know what? They give it to us in radians, so let's figure that out. So first I would have 2 pi, which I see my denominator is 3. So I'm going to say this is 6 pi over 3, and then it goes 2 pi over 3 more. So that means we're dealing with 8 pi over 3. And then to convert that to degrees, I would say 8 pi over 3 times 180 over pi. The pi's would divide out. 8 times 180. Oh, that's the division symbol. Don't want that. 8 times 180 is 1,440, and then divide that by 3. And sure enough, I get 480 degrees. All right. So hopefully we're feeling confident about graphing angles in standard position. We learned a lot in these notes. We learned about positive and negative angles. We learned about coterminal angles, reference angles, all sorts of cool things that we have going on here. We learned about reference angles as well. We're feeling pretty good. All right. So feel free to look at those sample problems if you want a little more practice with these. That would be fine. Otherwise, go ahead and get started on the practice problems. This is Mr. Carter signing off. I'll see you next time.